In these notes, we're going to talk about the two components of the universe, matter versus energy. So everything in this universe, from the tiny, tiny, tiny little germ that makes you sick every winter, to the stars and galaxies that you can see from a very, very far distance in the sky, everything can be wrapped up in one of two entities, either matter or energy. And so what we're going to do in this lecture is we're going to talk about the difference between matter and energy and a little bit about how they are related and intertwined. All right, first we're going to start with matter. And matter is what makes up everything in this world, basically, that you can see, you can touch, you can feel. Everything is made of matter, and matter is made up of atoms. And so you may have heard of atoms before. And in chemistry this year, we're going to take a look at the different kinds of atoms and how they're structured. And so just to kind of, introduce atoms, have little tiny parts to them as well. Three main, what we call subatomic particles called protons, neutrons, and electrons. And like I said, this is what one of the topics that we're going to study in depth this year in chemistry is the atom, its parts, how they differ from each other, how they interact with each other. Basically, everything that we observe in the world around us is an interaction of atoms. And so that's going to be a big key feature we're going to study this year in chemistry. Now, atoms can come together to make elements or compounds. And so we're going to start by talking about elements. So matter that is made up of the same type of atom. Okay, so like helium down here, okay, all of those little spheres there are helium atoms. So we would call that an element because in there's nothing but helium atoms. Likewise, we have oxygen in the air that we breathe. And oxygen is also an element because the little oxygen particles, even though there might be two of them together, the oxygen particles are made up of nothing but oxygen atoms. So they're the exact same type of atoms that make up the matter. So that's what we call elements. On the other hand, we can have different types of atoms come together to make what's called compounds. And so on the other hand, we've got compounds, matter made up of different types of atoms. So for example, water is made up of two hydrogen atoms bonded with one oxygen atom. So we've got two hydrogen atoms that are held together with an oxygen atom as well. So we have three total atoms in this compound. And we have two different types of atoms, hydrogen and oxygen. Another example of that would be carbon dioxide. That's the gas that we breathe out when we are respirating. And so carbon dioxide is made up of what we can see as C. That's for carbon atom. Okay, it's a different type of atom than the O, which stands for oxygen. And all this stuff we are going to get familiar with this year in chemistry. So matter is made up of atoms, and atoms can come together to either form elements or compounds. Now, whether we're talking about an element or a compound, all matter can be in three different what we call states. And you've probably seen this maybe since kindergarten or when you were little. But there's three different, or main different states of matter. We have solid, liquid, and gas, right? And so, as you probably know, anything in a solid state, the molecules in that substance are tightly packed together and not moving much, okay? So these guys are very rigid. They have a specific shape, specific volume, and the little particles are kind of just vibrating there, okay? So they're not moving very much, and that's why anything that's solid is usually going to be really hard, right? You knock your hand on the wall, your head on a tree, all those things are solid, and it hurts. Liquid, on the other hand, number two, Liquid have molecules that are loosely packed, and they're more free flowing, and we can see that with the arrows here that are like saying, oh, these guys are kind of moving around each other. They're still in contact with each other, but they're moving more freely around each other. And so what that entails is not a solid structure or something that's hard and has a fixed volume or shape, but something that is more fluid. It'll take the shape of whatever dish, flask, vase, cup, whatever kind of thing that you've got it in. Okay, so liquid, we've got molecules moving more freely, and they're loosely packed towards each other. Now in a gas, molecules are not packed together at all, and they're moving very fast. Okay, so we can see that they're spread out. They're not interacting at all with each other. They're just moving around each other. They're very fast and spread out. And so, the air around us is a gas. We can, kind of feel that in a sense, because, as you walk, you don't run into anything solid or even like a liquid or anything. It's just kind of free flowing around you. And those molecules are very much spread apart, and they're moving fast. All right, so taking a look at the states of matter from a molecular view, that's how we can describe solid, liquids, and gases. All right, so that was a brief little introduction for matter. We are going to dive deep into matter. Like I said, the different types of atoms, the structures of atoms, how they interact with each other to make compounds and molecules, all that stuff. But before we get there, what we're going to do in this lecture is look at the other entity of the universe, and that is energy. And energy also has many different types, and we're going to take a look at the two main types of energy, potential energy versus kinetic energy, and a few examples of each as well. So the first type of energy we're going to take a look at is what we call potential energy. And potential energy means stored energy. So energy that's not making something move, but has the potential to make something move, right? So if we think about this guy with a bow and arrow, right? As he stands right now, the arrow's not moving, right? The bowstring's not moving. It's drawn back, and he's holding it, all right? But it's got the potential to make that arrow fly. So we call stored or not moving energy potential energy. And there's different types or examples of potential energy. One of them, as seen in this bowstring, is what we call elastic energy. Elastic energy is the energy stored either in a wound spring or rubber band or this bowstring that's being pulled back and taut. All right, that's what we call elastic energy. As soon as we let go of the rubber band, let go of the bowstring, let go of the spring, something's going to start moving. The spring's going to start going up and down, up and down. The rubber band's going to fly, right? I guess that's a slingshot, actually. So whatever's in the slingshot's going to fly, right? The arrow is going to be shot and fly towards its target. Okay, so this is what we call elastic energy. It's stored potential energy found in a spring, a rubber band, a bowstring, a slingshot, all those kinds of examples. All right, we're going to take a look at three more types of potential energy. And the next one is gravitational potential energy. And this one's kind of, common sense. You are holding your phone. I see this all the time in class, right? You're holding the phone or it's in your pocket. You get up and it falls, crash onto the floor, right? Gravity. All right, gravity brought that down. So while it was in your hand or while it was in your pocket, it had the potential to fall, right? And so we call that gravitational potential energy. It had the potential for gravity to take it over, draw it down, and smash onto the floor. Hopefully it doesn't crack, but I've been witness to many phone cracks in the classroom, so just be careful. In any case, that's what we call gravitational potential energy. So it's like, this guy up here on the castle, he's got, I don't know, a bag of money, a bag of sand, I have no idea. In any case, right, if he lets go of that bag, I guess this is the one that's being dropped. If he lets go of that bag, boom, right, it is going to fall. And so that's what we call, again, gravitational potential energy. We'll talk more about that later in our investigation of energy. All right, the third type of potential energy is what we're going to spend a lot of time on this year, is called chemical potential energy. Chemical potential energy is energy stored in bonds between atoms. A classic example of stored chemical energy is burning something, right? So if you camping, you're burning wood, you were getting energy released, okay, from the bonds between the atoms in the wood, okay, and it making new bonds formed as it's burning, and so that is chemical potential energy, energy stored in the bonds between atoms, and we're going to take a look this year as to how much energy is stored between certain bonds. Different atoms will store different strength of energy there, okay, in the different bonds. For double versus single, if we have two oxygens bonded together versus a carbon and an oxygen bonded together, all those are going to have different amount of energy stored in those bonds. So we're going to take a look at chemical potential energy. All right, the last one that we're going to take a look at is nuclear energy. Okay, now nuclear energy and chemical energy sound very similar, but there's a huge difference, okay? An atomic bomb difference between the two. Okay, chemical energy is between atoms. All right, so if we had this green and blue atom, okay, between them in the middle, all right, if we kind of so to say, all right, between them is energy. Now nuclear energy is energy stored inside the nucleus of an atom. Okay, so we've got an atom. We're going to find out this year that inside the atom is nucleus with protons that are positive and neutrons that are neutral. Okay, and so inside this nucleus is a lot of energy as well, and we can harness that energy, and we call that nuclear energy, and that energy is super powerful. That's the energy that's harnessed in atomic bombs and in nuclear power plants and nuclear submarine vessels or other vessels that are powered by nuclear energy. Okay, so we've got, again, potential energy is stored energy. We can store it in elastic wound springs, rubber bands, all that stuff. Gravity is a potential energy. Any object has the potential to fall to the ground if it is held above the ground. We've got chemical energy, energy stored in the bonds between atoms. And last but not least, we've got nuclear energy stored in the nucleus of an atom. Okay, all right, so that was a little discussion about stored energy, energy that is going to make something happen or move, but hasn't moved yet. All right, so let's take a look at the other side of the coin, which is kinetic energy. Kinetic energy is the energy of motion. Anything that's moving is going to have what we call kinetic energy. And so the first example is kind of a blatant duh example of motion. Any object, okay, that is in motion has kinetic energy. Okay, and so this is basic. This example is usually for, objects that are visible. Okay, so visible objects in motion have motion kinetic energy. We're going to see that everything that we're going to talk about, all the examples that we talk about here are going to be something in motion, but we'll save, this first particular one for visible objects that you can see that are in motion obviously have kinetic energy. Now, the other examples on this slide are not so visible, okay, but they are definitely things that are in motion and have kinetic energy. So let's talk about the first one. The first one is thermal energy. We are going to deal a lot with thermal energy this year. Thermal energy is also known as heat, heating things up, right? So any object, if we talk about its thermal energy, we're talking about the energy of the atoms or molecules in the substance, all right? The movement of those atoms and molecules in a substance. So the faster a substance moves, the more thermal energy it has, right? The hotter the temperature. The slower the molecules move, the less thermal energy something has, and the cooler the cooler the temperature, right? So if we take a look over here on the left-hand side, we can see that here it says the longer arrows mean higher average speed. So if we take a look between example 1 and example 2, right, this guy is going slow and these ones are going fast. So the faster the molecules are moving, the more energy we have, therefore the more thermal energy or heat is being given off, right? So we can see that the one on the right, number 2, is definitely has more thermal energy than block number 1. Okay, so that's thermal energy. Now sound is another type of energy. Sound is the energy of and the vibrations of objects that eventually vibrates air, right? So dog barks, right? He is pushing air through his vocal cords, rough, rough, rough. That air, those air molecules, right, are bouncing off each other. They are definitely in motion. They set in motion the air molecules, right, outside of the dog. All those air molecules until they hit your, those air molecules hit your ear. So it is definitely kind of a wave of moving molecules, right? And in this case, moving air molecules. So sound is a form of kinetic energy because we've got moving air molecules hitting your ears and sending a signal to your brain that says, hey, that's the sound. That's the sound of a dog. That's the sound of Mrs. Creo's voice, right? That's the sound of a really good song. All that is kinetic energy. Now, the next, second to the last example we're going to talk about is electromagnetic energy. This is the energy found in the electromagnetic spectrum. So everything from radio waves, you crank on the radio in your car, right? If you do these days, I don't know, a lot of people just might use your iPods or whatever. In any case, the radio waves in your car are a type of energy. So it's kind of the radio. I don't know. Radio waves blow my mind still. I still don't understand how you could send information, sound, and all that stuff through waves in the sky. It's really cool. Anyways, I don't want to get on that tangent. Radio waves are really long waves. Okay, their wavelength is quite long. Okay, so they're low energy waves. Low energy. And we'll talk about this later in the year too. Microwaves, okay, are a little bit shorter, so they're still relatively low energy waves, but they're a little bit shorter. We've got infrared radiation, all right, visible light, so light, as we see it in all the colors, are a form of kinetic energy, okay. Ultraviolet or UV energy, we get a lot of that from the sun. Now that, a lot of our, what's it called? A lot of our atmosphere, okay, has been eroded away with some of the chemicals that humans have made over the years. So a lot more ultraviolet energy is coming from the sun, and so we get sunburns and all that stuff a lot easier these days. All the way up to X-rays. These guys are super short. These guys are high energy waves. All right, and last but not least, the highest, shortest, most high energy type of kinetic energy in the electromagnetic spectrum is the gamma rays, which are super high energy waves that are given off in nuclear bombs and nuclear decay, radiation, that kind of thing. Okay, so that's the electromagnetic kinetic energy that is found in the movement, of radio waves, microwaves, gamma rays, all that stuff. All right, last but not least, we've got electricity. Electricity is a type of kinetic energy because it's the movement of electrons down a wire or through a battery. All right, so you plug your phone in every day to get it charged. What you're doing is you're harnessing the movement of electrons through the wires in your house, right? Through the wire that's connected to your phone, and those electrons are being stored in the battery. And so when you unplug it, we got lots of potential. It's actually chemical potential energy in that battery that's going to be used when you are on your phone as it's not plugged in. So here's kind of a way that the battery works. It's got stored energy in the battery, and as soon as you turn it on, like a light bulb or your phone or whatever, right, we have a flow of electrons. Okay, flow of electrons from the battery to your device and back again. Okay, so that is what we call electricity, the movement of electrons down a wire or through a battery. All right, so those were the different types of kinetic energy. We talked about potential energy, and we also talked about matter. All right, so there's definitely a distinct difference between matter and energy. Matter is the stuff that makes up this world that you can, see, touch, feel, carry, even so small that you can't really see, touch, feel, but it's there. Energy is making matter move. So they always are related, or not necessarily related. Okay, so interacting with each other, I guess, would be a better way to put it. So matter and energy are always interacting with each other. Energy making matter move, or having the potential to make matter move. All right, so that's the difference between matter and energy. We're going to talk about and investigate both and how they interact this year in chemistry, and we're going to focus mostly on a molecular, atomic, super small level of our world. All right, so that's it.